Welcome to this Vertex video tutorial. My name is Ingmar, and in this chapter of our Canvas Surface Output series, I'd like to show you a nifty new workflow handling a special but not uncommon situation we all know too well from the real world. I'm talking about a situation where our real-world physical outputs, let that be projectors, screens, LED walls, whatnot, where they have different dimensions, pixel densities, and aspect ratios. And yet, the eventual outcome of our production, we all like to see our content on those different screens in perfect alignment. Let's say we need to arrange a show on two different video outputs that are only similar in height. Output number 1 has got a full HD resolution in 16:9, whereas output number 2 is maybe an old XGA projector with 1024 by 768 pixels in 4:3. Now the question is, with this difference in pixel density and aspect ratio, how can we ensure continuity in our displayed content between the two screens? Well, let me show you how it's done in Vertex. Let's take a look at our system's output setup first to show you my two outputs in their varying size and resolution. Eventually, we'd like to display them, of course, in the same dimensions. Output number 1 has got the standard Windows desktop size and resolution, and output number 2 is that XGA projector I was talking about. Let's take a look at our canvas, which has by default the same size and resolution as output number 1. And if I move the now pointer over my test content, you see that that content itself is a little too wide for our canvas. And since we need a larger canvas to reflect our two-screen setup anyhow, we're going to change the size and the dimension of our canvas by selecting it in the Project Explorer and moving to the Inspector window, Settings tab. And the second property from the top is the Dimensions parent property. If we click on it, it opens up and shows width and height in meters. Now let's take a look at the real world for a second, where our two outputs together have got a total width of 17.5 meters. And back in Vertex, we want to change the canvas's dimensions so that its width is wide enough for our total screen size in the physical world. 17.5 meters. Let's punch those in. And back in the render editor, we now see that the canvas has got a new width that is beautifully fitting our really wide test content, and thus eventually the two screens next to one another. And in order to get there, we need to right-click on the canvas, create a new surface from the context menu, and choose output 1. We'll leave the pixel size as it is because it already corresponds with the size of our output. Canvas location is canvas offset, and we'll change that to -720 pixels so it's on the left side of our canvas. And now finally, we'll get to the main attraction of this presentation here. The new function, Use Canvas Dimensions. We definitely want to enable that one, because then and only then will the dimensions entered below scale the new surface so that it fits the dimensions of our canvas. Confirm with OK, and the new surface will appear right where we want it on the canvas. Now let's quickly create a second surface on the right side. Right-click, choose Create New Surface from the context menu, and this time we want to set system output to number 2. Also, this time we need to change the default pixel size so that it corresponds with our output of 1024 by 768 pixels. Now for canvas location, we need to give it a different offset because this time we want surface to appear on the right side. So let's set it to 683 pixels. The Use Canvas Dimension feature is still enabled. So all we need to do is change the actual dimensions. The width is not 10 meters, but 7.5 meters. The height we'll leave as it is because it needs to be the same height as surface 1 and as the canvas. Confirm with OK, and surface number 2 has been created and assigned to the second XGA output. And as you can see, both surfaces are in perfect alignment with the canvas and with one another, despite their different resolutions and different pixel densities of their outputs. And to really illustrate what's going on behind the scene, under the hood, so to say, so let's change the render editor's view from canvas to our system's output. And this shows our two outputs in absolute pixel sizes next to one another as if they had the same pixel density. So please keep in mind that the system view in our render editor only processes the absolute pixel sizes and does not compensate for dimensions. So let's quickly change back to our canvas view, because this is what we see and this is what we'll get. And that's a wrap. That's how you adjust the dimensions of canvas and surface to match the final dimensions of your physical outputs in the real world and align any possible difference in pixel density. Thank you very much for watching. Bye bye.